Something important is happening far above our heads, in a part of the atmosphere we don't usually think about, the stratosphere. Over the Arctic, temperatures at around 30 kilometers altitude are rising dramatically in a matter of days. This phenomenon is known as a sudden stratospheric warming, and while it happens high above the weather we feel every day, its consequences can reach all the way down to the surface. During a sudden stratospheric warming event, the polar stratosphere warms by tens of degrees Celsius in an extremely short time. This rapid warming disrupts the normal circulation of the polar vortex, a large-scale system of strong westerly winds that usually keeps the coldest air locked near the pole. As the stratosphere warms, those winds weaken, slow down, or in some cases even reverse direction. The polar vortex loses its coherence, stretches, or splits into multiple smaller cores. Once the polar vortex weakens, the entire circulation pattern across the Northern Hemisphere becomes more unstable. Cold air that was previously confined to high latitudes becomes far more mobile. Instead of flowing smoothly around the pole, it starts to spill southward in uneven, sometimes abrupt surges. In the weeks following a sudden stratospheric warming, Europe often experiences a higher probability of Arctic air intrusions. However, the way this cold air reaches the continent can differ significantly from what we have seen earlier in the winter. Until now, most cold outbreaks have been driven by strong interactions between deep cyclones and persistent blocking anticyclones, creating classic north-south transport corridors for polar air. The upcoming pattern is different. Instead of relying on intense cyclone-anticyclone coupling, cold air is increasingly being transported by individual anticyclonic cores that are circulating from the higher latitudes towards the southern regions. These high-pressure systems carry cold, dense air masses with them and can move them southward toward Europe on their own, without the need for strong cyclonic forcing. This is a direct consequence of a weakened and more fragmented polar vortex, which allows high-latitude anticyclones to become more influential. At the same time, the Azores High is shifting into an unusually northeastward position, with its center located close to the southwestern coast of Portugal. This placement is far from typical for late winter and plays a key role in the current setup. From this position, the Azores High helps redirect polar air masses towards Central and Eastern Europe, effectively acting as a steering mechanism rather than a blocking one. As this cold air advances south and east, it encounters much warmer air and enhanced moisture over the Mediterranean basin. The temperature contrast between these air masses creates a highly favorable environment for cyclogenesis. As a result, cyclones can form or intensify rapidly, particularly over the central and eastern Mediterranean, before moving toward the Balkans and further north into Eastern Europe. Regions such as the Balkans, Romania, Moldova, and Ukraine become especially exposed under this configuration. The interaction between polar air and Mediterranean moisture increases the likelihood of active weather systems, capable of producing significant precipitation, strong winds, and sharp temperature contrasts. Depending on the exact thermal structure, these systems can bring heavy snowfall, freezing rain, or prolonged cold spells. Another important factor reinforcing this pattern is the extensive and persistent snow cover across the East European plain. A well-established snowpack enhances surface cooling, strengthens temperature inversions, and promotes the development of surface high pressure. This snow-induced anticyclone further supports the continuous advection of cold air, creating a feedback loop that helps maintain below-average temperatures over large areas. This surface response is also linked back to the stratospheric disturbance. A weakened polar vortex favors descending air motions and anticyclonic tendencies in the troposphere, especially over Eurasia. In other words, the effects of the sudden stratospheric warming are not limited to a single cold outbreak, but can shape the broader circulation for weeks. In summary, the ongoing sudden stratospheric warming has fundamentally altered the large-scale atmospheric pattern across the Northern Hemisphere. The weakened polar vortex allows cold Arctic air to reach lower latitudes more easily, but through mechanisms that differ from earlier winter episodes. Independent Greenland anticyclones, an unusually positioned Azores High, Mediterranean cyclogenesis, and extensive snow cover over Eastern Europe are now working together to redefine the weather pattern across Europe. This does not guarantee extreme conditions everywhere, but it significantly raises the probability of impactful weather, particularly in Central, Eastern, and Southeastern Europe. As models continue to adjust to the evolving stratospheric influence, the details will change, but the signal itself is clear: the atmosphere has entered a new phase, and Europe is likely to feel its effects. If you like this type of content, we would deeply appreciate if you would leave a like and subscribe to our channel. The weather is very dynamic, and together we can discover its beauties. Thank you for watching.